Open your book to page 235, and this is lesson 8.5a, and this is about adding and subtracting polynomials. So first, let's go over the definition of the polynomial in variable x. So polynomial means that every term will have this kind of format. You have a number, you have the variable, and you have the exponent. Okay? And so a is any real number, and n is a whole number. Okay? And so this is a polynomial. Again, n is a whole number. That means it cannot be fraction or decimals. Okay, so let's go to examples of polynomial. So example 1a, you have 3x, right? So again, this looks like that, right? So that's the a, and the n is 1, right? So this is example of polynomial. Again, all these are example of polynomials. So you got 4x to the 4 minus 2x squared. So to be a polynomial, every term must be polynomial. So you can look at this is follow this form, right? So this is that, right? So that's the b. Again, all these are example of polynomials. So for in order to be polynomial, every term must follow this form. So c, you got 7x squared minus 5x plus 2. So you can look up here. So this is the a, the x, the n, right? So that's the a, the x. Now there's no number. No number means it's 1. Okay? Now over here, this is a polynomial because that's the a. And over here, when you don't see anything, that means it's x to the 0 power. So this is 2 power, 1 power, 0 power. Okay? So so x to the 0 power equal to 1, right? Okay? So that's where that is. So even when you don't see a variable, that means it's x to the 0 power. So this is a polynomial. Okay? It's just that it's x to the 0. So x to the 0 power, so it's 1. So that's why you don't see it. You don't write that. Okay, let's go to D. You got x to the 3 plus 3x squared plus 3x plus 1. Right? Again, so the a is 1, right? So it's the number, variable, exponent. Number, variable, exponent. Number, variable, exponent. So in this case, exponent is 1. Over here, you got the number. Now again, we don't see anything means the variable to the 0 power. That's what that is. Okay? So a number is a polynomial. Okay? What it means is that it's the variable to the 0 power. That's why you don't see any variable. So E, again, this is a polynomial. We cover this, right? So again, this is a polynomial because this is the 5x to the 0 power. So this is a 5x to the 0 power. Okay, let's go to F. You got 6z to the 3 minus 3z plus 1. Okay, again, all these are example of polynomial. Okay, so let's go to example 2. Let's look at example of non-polynomial. Okay, so these are polynomial. Okay, so this is example of a polynomial. So example 2 on page 236. So A, you got 4x to the minus 2. Okay, so if you look over here, you have to be a number, variable to an exponent, and this has to be a whole number. Whole number means 0, right? Remember, whole number is equal to 0, 1, 2, 3, and go on forever, right? So over here, this is negative 2, so this is not a whole number. So this one is not, right? Okay, go to B, 2 over x minus 5. So again, this one does not follow this. Okay? So again, it doesn't look like that. So it's not a polynomial. Okay? And especially you have this over here. So this is like grouping, right? So you have a group. So this is not. So you go to C, you got square root of 2x plus 3. Again, this is a group. So this does not look anything like that, right? So again, you have to be a number, variable to the exponent. That's it. Okay? So all these are weird things. So these are not polynomial. Okay, let's go over. Next thing is that the polynomial can have more than one variable. Okay, so page 236, example 3a. So you have 5x squared y. So we cover this over here, right? So again, this is only one variable, but you can have more than one variable. You can have the y to a number, z to a number,
and you can have m to a number. So you can have as many variables as it calls for, right? So you can have any number of variables. So this is example of polynomial in two variables. And next one is negative 3xy cubed plus 2x squared y. So again, all these are polynomials. As long as follow the number, the variable to exponent, number, variable to exponent, and you can have more than one variable. So again, see that? So number, variable, exponent, number, variable to exponent. So all these are example of polynomials. So C, you got 4x squared y squared minus 7xy plus 6. So again, all these are polynomials. D, you got x to the 3 y2 minus 2x plus 3y squared minus 1. So again, all these are polynomials. Yeah, you follow the format of ax to the n, right? Number, variable, exponent. So you have the number, which is 1, exponent, variable, exponent, variable, exponent. Okay? So it's just that you have more than one variable. Okay? Okay. So E, you got 7uv to the 4 minus 5u squared v plus 2u. Okay? Again, number, variable, exponent, variable, exponent. Number, variable, exponent, variable, exponent. Number, variable, exponent. Okay. Okay, the next thing you have to do is figure out the degree of a term. Degree of a term basically means the power or the exponent. So example 4, example 4a, 5x to the 3. So this is the third degree, okay? Because the exponent is 3. So the degree is 3. So this is the third degree, okay? Okay, so if you, let me go and write it out. So it's more clear. So this is the third degree. For B, you got 6x squared y. So this is also the third degree. Because you got 2 here, you got 1 here, right? So 2 and 2 plus 1 give you 3, right? So this is the third degree. Okay, go to C, 14. Now that's not variable exponent, so this is the 0 degree. Because that's no variable, right? This is like x to the 0 power, so this is 0 degree. And you go to D, negative 2u to the 3 vw squared. So you got 3 here, 1 here, 2 here. So this is the 6th degree. Okay, again, you got 3 from here, 1 from here, 2 from here. So 3, 1, 2, you add all together, that gives you 6th degree. So this is the degree of a term. Okay. Next, let's go to degree of a polynomial. Degree of the polynomial means the highest, the degree of the highest term. Okay, it follows the degree of the highest term. Okay, the term with the highest degree. So let's look at some of the example. Example 5a, you have 9x to the 3 minus 7x plus 5. So this one has 3. Okay, this one has 1. This one has 0. So the degree of the polynomial, you take the highest one. Don't add, okay? So in this case, this polynomial is third degree. Okay, so this polynomial is third degree. Okay, let's go to B. You have 14xy to the 3 minus 11x to the 5y plus 8. So for the entire polynomial, you have to figure each individual one first.
So this one is 4, right? You got 1 and 3, so this is 4. This is 5 and 1, so this is 6. And this one is 0. So this one is the 6th degree. Okay, so this polynomial is 6 degree. Okay, let's go to 5c. You have 6a squared b c to the 3 plus 12ab 6 c to the 2. So this one has 2, 1, 3, so this one is 6. This one is 1, 6, and 2, so this is 9. So this one, in this case, this is the 9th degree. Okay. Okay, so this is the 9th degree. Okay, you take the highest one. Okay, now let's go to example 6. This is to arrange polynomial in a descending order, means you go from highest to lowest. And sometimes you will be in the ascending order, means you go from highest to lowest. So you kind of have to follow the instruction. So on page 237, example 6, so you got 5 minus 2x squared plus 4x. It says arrange in the descending order powers. Descending means going down. So you want to start from the highest and you go down, okay, based on the x. So that means you will be negative 2x squared plus 4x plus 5. So negative is part of the term. So you can arrange in the descending order, means going down from the highest to lowest according to the variable x. So you can make sure you understand what they tell you. Okay? So example 7. Example 7a. You got 3x3 y plus 2x squared y squared minus 5xy minus 10. And the instruction says, so there are different parts. So first, you want to, in the descending order of, so you have the part A, part B for part A. So this is kind of weird. Okay. Okay. So part A, you want a descending power, okay, of x. So based on the x, so you're going to have a 3, 2, 1, 0. So this is already kind of fine already. Okay. So you're going to get 3x cubed y plus 2x squared y squared minus 5xy minus 10. So that's already in the descending order of x. Now b, you want a descending power of y. So you're going to do it based on the y now. So you have to start with the highest one. So you got 2x squared y squared. And then next one is this one here. Okay. Now notice they're tied, right? So you got y and the y. So you go to the tiebreaker. So you go to the x. So this one is higher. So it's, again, you want to go from highest to lowest. And that. And after that, that's it. Okay? So you can make sure you understand what I want you to do. So again, descending power means you go from highest to lowest. And on here, it's based on the x. So you got x to the 3, x to the 2, x to the 1, x to the 0. Over here, it's based on the y. So you go y squared. And over here, you do the y to the 1, y to the 1. But over here, is the y is tied. So you need to go tiebreaker, using the x as your tiebreaker. So you go x to the 3 and then x to the 1. And after that, you got the y to the 0, right?